What is Apache Spark? Why PySpark? Need for PySpark? PySpark, Python, and Scala. PySpark features, real life usage of PySpark, PySpark job market. So, Apache Spark is an open source, no licensing required. Yes, distributed execution, cluster computing, right? With parallel process style. With in-memory computation used for large scale data processing. Yes. It's a general engine for big data analysis, processing, and computation. So, so in-memory computation means storage and processing happening within the memory level, that is within the RAM level, right? Yes. Why PySpark? PySpark is the Python API to use Spark. Why PySpark means PySpark is the Python API to use Spark. PySpark is used for running distributed SQL, creating data pipelines, ingesting data into database, machine learning algorithms for graph algorithms for in-depth data streams. So PySpark is the it's a very demanding tool among the data engineers today to work with huge data, big data, right, with bigger data sets. Need for PySpark. So huge data, right? From that we need to extract the required data, valuable data, right? Yes, which consists of the customer preferences, market trends. So we require some tools. So efficient tools, scalable and flexible tools to crack big data and gain benefit from it. So PySpark is such a kind. So combining Python plus Spark will be the very efficient for the world of big data. That's why Apache Spark came up with a tool called PySpark. PySpark is 100 times faster than Hadoop. So previously Scala was used a lot. Now Python is used. PySpark features in-memory computation. Memory level storage and processing, lazy evolution, on demand executing the flow by making an action. Fault tolerant, a Spark has powerful fault tolerant model. Immutability, all the original data objects are immutable. Partitioning, Spark data is divided into multiple partitions and are distributed across multiple systems. Persistence means reusing the already executed transformation. Here, no need to re-execute. So real life usage of PySpark, where it is used in commercial sectors, in healthcare, in entertainment industry. Yes. Trade and e-commerce, right? Trade and e-commerce for advertising, right? Like Flipkart, Amazon, they're using PySpark today for advertising recommendations, right? Even like tourism industry for giving advices to the travelers, right? Yes. So here, if you see Apache Spark, Spark were developed by Matai Zaharia. Spark was developed by Matai Zaharia in AMB lab. Mhm. It was open sourced in 2010. Was donated to Apache Software Foundation. It was donated to Apache Software Foundation. Spark was developed by Meta Zaharia in AMP Lab. It was open sourced in 2008. It was donated to Apache Software Foundation in the year 2013. It is an open source distributed execution framework in memory computing with parallel process style for large scale data processing. Apache Spark can be squared. Apache Spark can be coded with Scala default. Apache Spark can be coded with Scala, it's coded with Python, Java, or language. Spark can be coded with Scala, Python, Java, or language. By default, Spark built using Scala language. By default, Spark built using Scala language. Can be coded with Scala, Python, Java, and or language. Right there. So by default, Spark built using Scala. So today, even Python is mostly preferred. Mm. PySpark is mainly designed for PySpark is mainly designed for batch applications, iterative algorithms, interactive queries. PySpark is mainly designed for batch applications, interactive algorithms, interactive queries, and streaming. Okay, it's mainly designed for batch applications, iterative algorithms, interactive queries, and streaming. Batch applications means user non-interactive applications. Online applications and batch applications. Hadoop and Spark both only for batch applications. Online applications means user interactive applications. Batch applications, user non-interactive applications. Iterative algorithms. Most of these data science algorithms are iterative. Keep on applying that algorithm on the same data. So until the error becomes zero, iteratively. Interactive queries. some kind of queries, right? Yes. And also for streaming. Okay, now talking about the Spark data objects. RTDs, resilient distributed data set. What is that? Resilient distributed data sets. RTDs, resilient distributed data set. Spark data objects. Spark data objects, right? Are called as RTDs. Spark data objects are called as RTDs. Spark data objects. This RTDs. RTDs are subdivided into partitions. These partitions are distributed. These partitions are distributed across these partitions are distributed across multiple ramps of multiple slave nodes. Spark data objects are called RTDs. RTDs are subdivided. These partitions are distributed across multiple ramps of multiple slave nodes. RTD programming style. RTD programming style is to data flow, right? RTD programming style is data flow. Data flow is a sequence collection of data flow. Data flow is a sequence collection of pipes. A pipe is any data operation. A pipe is a data operation. Understand this, right? Yes. Data flow is sequence collection of pipes. Sequence collection of pipes means RTDs.
Data flow is similar to data procs, sir.
Data flow is a sequence collection of pipes. I'll say what is the data. See, a pipe, see sequence collection of pipes. Data flow is sequence collection of pipes means what is a pipe? It is an data operation such as loading data, such as loading data, transforming data, transforming data, filtering data. Filtering data, grouping data, filtering data, grouping data, merging data, sorting data, etc. Sorting data, etc. Loading data, transforming data, filtering data, grouping data, merging data, and sorting data, right? Sorting data. Loading, transforming, filtering, grouping, merging, and sorting data.
Okay. No, I did it. So
Understood, right? What is it? Data flow is a sequence collection of this. Collection of pipes. Pipes means pipe is a data operation, such as loading, transforming, filtering, grouping, merging, sorting. For example, the output of one will be the input to the next. What do you mean by data flow? Nothing but the output of one will be the input to the next. It continues. In Spark, data flow is executed. Data flow is executed in sequence. Data flow is executed in sequence. That is RTD by RTD, RTD by RTD, one after the another. With in-memory computing feature. Within memory computing feature. And persistence feature. See, data flow is executed in sequence, RTD by RTD, one after the other, within memory computing feature and persistence features. But you may ask, where is the parallel processing here? Means, but if RTD has 30 partitions, then they can execute in parallel. If RTD has 30 partitions, then they can execute in parallel. Then they can execute in parallel. That's it. For example, RTD1, P1, P2, P3, P4, P10, 10 partitions. See, yeah, RTD is divided into 10 partitions. These 10 partitions can execute parallelly. P1 in S1, P2 in system 2, P3 in system 3, and this is in system 10. So these 10 partitions can execute parallelly. See, if you want to understand about the persistence feature, persistence of what is persistence in Spark, important feature, right? That is what is persistence. That, and secondly, how these RTDs are computed, how Spark computation is going, how this persistence happens, right? For example, R4, R5, yes. Yeah, am I audible now? So there is a power cut. So are you able to hear my voice now, everyone? Yes. Unknown error occurred.
Yes, sir. We are
Yes,
able
sir.
to hear.
Let's check this R1, R2, R3. How this output of this R1 output will be taken as input by this. See, first before I go with this diagram, right, we need to check with this another. See, RDD1, it's a Spark data object. The output of this will be taken as input by this. The output of this is taken as in. See, the output RTD1 output is taken as input by RTD2. RTD2 output is taken as input by RTD3. RTD3 output is taken as input by RTD. RTD4 output finally collected. This is a data flow. This is the data flow. Entire thing. This is a flow. Sequence collection of pipes. At each pipe, first thing loading happens. Here filtering, here grouping, here matching. See, RTD1 has 10 partitions. Just a second, just a second. RTD1 divided into 10 partitions, stored in 10 systems, executed parallelly. After the execute, see here, I'll ask a query. See this RTD1, 2 TB, RTD2, 2 TB, RTD3, 2 TB, RTD4, 2, totally 8 TB. Do you think all this 8 TB data will be stored in the RAM? Hello?
Yes, sir.
No, sir.
In Spark is a in-memory computation. Yesterday I was talking, right? Spark is what? In-memory computing system. Yesterday I was briefing you, right? Yes. I say space for Spark. So in-memory computations, Spark is a in-memory computing system. In-memory computing means what all the data, Spark data objects, everything, storing and processing happening within the memory level. Storage and processing happening within the memory level. 1 second here, as I was talking, right? In-memory computing, it is a in-memory computing, right? In-memory computing feature. In-memory computing means storage and processing happening within the memory only. I was asking a query, right? All this RTD, think that each one is of 2 TB, 2 TB, 2 TB, total 8 TB. Will it fit into the RAM? 8 TB RAM, huge. All these RTDs can't be accommodated. All these RTDs can't be accommodated into the RAM. No. First, this RTD1 loads into the RAM. Loads into the RAM means 2 TB RAM means into 10 systems, 10 partitions. This RTD divided into 10 partitions stored in 10 systems. Okay, processed parallelly, the output whatever taken by the RTD2. When RTD2 has taken and is ready, when RTD2 is computation finished, all the RTD1 partitions will be removed from the RAM. RTD1 and its partition, everything is going to be removed from the RAM. Now, what is in the RAM? Everyone try to respond. What is in the RAM now? Hello? What is within the RAM?
Tools.
RTD2. Now, RTD2 partitions again will be loaded into the systems, will be computed parallelly. Multiple partitions will be there, the partitions stored across multiple systems and processed parallel. The output of it again taken by RTD3. One RTD3 taken the input and processed, then RTD2 partitions, this removed from the RAM. When RTD3 computed and this output is taken by RTD4, then RTD3 partitions and RTD everything will be removed from the RAM. Now RTD4 processing, RTD4 processing, right? Yes, the output is collected. Output is collected by the client. And finally, this RTD4 also removed from the RAM. Output finally got the output, right? Now what is in the RAM? What is there within the RAM? What is there within the RAM? Hello? No RTD in the RAM?
Yes, sir.
No RTD in the RAM. Next, you can trigger the next flow, next data flow. Now the total RAM is free. You can also once again load one by one RTD, compute it, and collect the output. And this. Understood, everyone? Hello? How
Yes, sir.
how the RTD computation? The output of one will be two RTDs can never execute in parallel. Why? Two RTDs can never execute RTD by RTD in sequence. Why two RTDs can't execute in parallel? Until RTD1 output is given as input to RTD2, RTD2 can't be computed, right? Until RTD2 output is given as input to RTD3, RTD2 can't be executed. Hmm. Okay. Now come back to this flow. Come back to this flow, right? Yes. R1, R2, R3, R4, R5, R6, R7, R8. Yeah, Satyavamas, any query, you got some query you said?
Yes, sir. Previously, means two RDDs cannot be executed parallelly, you said, right, sir?
Mhm.
But first RDD, it is will be partition, 10 partition, right, sir? Generally, one partition having multiple RDD, right, sir?
See, RTD is one, RTD, think it is a file.
Hello, am I audible?
Okay. Sorry. Some query was asked, right? Yes. So here, understand clearly RTD1 partitions. RTD1, assume this is a file. RTD1 is a file. The file is divided into 10 partitions. One partition won't have RTD. RTD thinks this is a file. The file is divided into 10 partitions. The 10 partitions stored on 10 systems. Means that the data is stored in 10 RAMs of 10 systems and are processed parallelly. After processing, the output collected by this RTD2 as the input type. Once this RTD2 computation finishes, RTD1 removed from the RAM. Understood now? Yes. Satya Vemas.
Yeah, this one is fine, sir. But previously, one partition is a data flow. Data flow contains group of RDDs. You said right, sir. That's what I got confused.
This is a data flow. This one data flow.
Oh.
Data flow is a sequence collection of RTDs, right?
Yeah, but one partition contain multiple data flow, right, sir?
Who said?
No, I'm thinking. Oh, sorry, sir.
No. In RTDs divided into parties here, clearly, if you see this, observe here, not this. RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple nodes. RTD programming style is data flow. Data flow is a sequence collection of pipes. Collection of RTDs. At each RTD, some first RTD loading happens, second RTD transform, third RTD filtering and grouping. In this way, it is going to happen. Yes. Understood, everyone? Now, one more example here. 1, 2, 3. This is flow 1. This is the flow 1. This entire thing is flow 2. This entire thing is what? Flow 3. Flow 1. R1, R2, R3, R4, R8. R1, R2, R3, R5, R8. Flow 3. What is it? Try to say.
R1,
R1,
R2,
R3, R6, R9. See, Spark is a lazy.
R6, R9.
R6. Spark is a lazy evaluated. Spark is lazy evaluated, right? Yes. Okay. 3 flows. See, Spark is a lazy evaluated. Until you perform an action, the flow won't execute. To execute the flow 1, I need to make an action. For example, flow 1 to execute. I am saying R8 dot action. Means from R1 to R8, it is going to execute. R1, R2, R3, R4, R8. When R1 is ready and loaded and computed, R1 output is taken by R2. When R2 is ready, R1 removed from the RAM. When next R3 is ready, R2 removed from the RAM. When R4 is ready, R3 removed from the RAM. When R8 is ready, this is removed. When the output is collected, this R8 also removed. Now, what is present in that RAM? No RTD in the RAM, right?
Yes, sir.
Flow 2 also. If you want to execute flow 2, compulsory. And the last RTD, what is that? This R7, sorry, this is R7. It's R7 dot action, R7. R8 dot action, I should say. Then from the root first RTD to the R1, R2, try to say, everyone, try to say R3,
R3, R5.
R5, R8. When
So
this is ready, this computes. When this is ready and computed, this will remove from the RAM. This is removed from the RAM. When this is ready, this is going, the previous one will be removed. This will, final output is collected. Final output is collected. So when the last RTD, the output is collected, the output is collected. The last one. Now, no, here also no RTD in the RAM. See that last one, flow 3. Try to say R9 dot action. If we say it is going to execute from that R1, R2, R3, R6, R9. R1, R2, R3, R6, R9. R1, R2, R3, R6, R9. R1, R2, R3, R6, R9, right? Okay. So when R1 is ready, when R2 is ready, R1 gets removed. When R3 is ready, this gets removed. When R6 is ready, this gets removed. When R9 is ready, this also gets removed. When the output is collected, this also removed from the RAM. Here, what is your observation?
So one flow is at a time, only one flow is executing.
See, 1 second. I'm coming to it. So first flow 1, flow 2, flow 3 executed. After flow 3, no RTD in the RAM, right? Or again, RAM is empty. Means if you observe, every time I'm executing from the starting, again I'm executing, even though the first 3 steps are common in everything. The first 3 steps are common in all that. Again, you are executing R1, R2, R3, R1, R2, R3, R1, R2, R3. So in such case, Spark has got the concept of persistence. Make this R3 persist. Make the RTD persist means make this RTD available in the RAM so that it will give output to the other flows. So every time you are re-executing from the starting, even though first 3 steps are same. So what happened? First flow you execute. Second flow onwards, don't again re-execute from R1 to R3. Directly from R5, R8, R6, R9. Because R3 is giving the output, right? To the second flow. Understanding everyone. First flow executed totally. Now you are persisting R3. Persisting R3 means, what do you mean by persisting R3?
Saving into
Even though the next RTD ready, the previous RTD won't, R3 won't be removed. When R5 is ready, R3 won't be removed. So in the flow 2, the flow will be starting from here to here only. The first 3 step it won't execute because already R3 available in the RAM. What is the necessity again of executing R1, R2, R3? To get the R3 output, I need to execute R1, R2, R3. But R3 already in the RAM, right?
yes, sir.
In the first flow, one, when R2, R1 removed, when R3 is ready, R2 removed. When R4 is ready, R3 won't be removed because it is persisted RTD won't be removed. Finally, when the flow 1 executed, how many RTDs in the RAM?
RAM 1.
Only one RTD in the RAM, right? Only one RTD in the RAM. That is R3. Flow 2, where I need to start from? No need to start from the beginning. From R3 to R8, and R8 output will be collected. Because R3 is ready, R3 output will be given to R5. Flow 3 also, right? I no need to execute from the starting. But if you have got, observe this. R1. Yeah. If you are persisting this, right? See, R1 to R50, R1 to R50 means first flow you execute, but second flow, no need to execute the first 50 steps, directly 50 50 onwards you can start because 50 is available in the RAM as you are persisting it. Understood the advantage of persistence, everyone? Hello?
Yes, sir.
Because it is available in the RAM, so the other flows can make use of this. From R50 you can start, means 50 steps are decreased. For the third flow also, that as R50 is available, R50 to R90 you can go 50 steps are decreased. So we need to persist the one which is mostly used by different flows so that it will be available in the RAM, use output to the other flows, right?
Yes, sir.
So next, this is just an overview about this RTD computation. In the next week, I'll be discussing clearly step by step RTD computations, steps in RTD persistence, what are the rules to be followed, right? Okay, fine. Understood, right? Any queries you got as part of today's RTD's computations? Okay. So in everything is RTD, in Spark everything is an RTD, but later after RTD you got data frame concept. RTDs are the basic entities, data frames are mostly used. RTD plus a schema, RTDs with a schema is nothing but a data frame. Okay. So sorry, there is a power fluctuation since evening. There is a power cut since evening, right? So I'm running with the backup power. The laptop backup power is also completed, right? So the people who are attending Hadoop class, I cannot go with it. There is no power. So those people who are attending Hive, you'll have the class in the next week. Next week, I'll complete that Hive. Parallelly, you'll be attending PySpark, right? Okay. So the PySpark introductory notes I'll be forwarding. Check with that. Okay. Next week, both the PySpark and Hive, both you will be having, right? Hive will be completed next week. Then only PySpark will be continued.
Same timing, sir.
Yes, yes, timings will be mentioned. Same evening, right?
Yes.
Same 7 o'clock. So if anyone, if you're not enrolled for PySpark, those who are attending for PySpark, right, check with that. Next week, you will be getting a new link. Link will be changing. Still, if anyone, if you're not enrolled for PySpark, if you're attending only for there's some people who are attending only for PySpark, right? Yes, check with that. Okay, fine.